and welcome again to my channel. Today we'll be solving another LeetCode question number 581, and it is marked medium. Given an integer array nums, you need to find one continuous subarray such that if you only sort this subarray in non-decreasing order, then the whole array will be sorted in non-decreasing order. Return the shortest such subarray and output its length. So let's see the first example. This is the first example and the answer is 5, right? Why? Because if you see this two pair of numbers and these pair of number are reversed, right? If the whole array were to be sorted in ascending order, it should have been 2 4 6 and 9 10, not 10 9, right? So that means this is the first index where the error is occurring and this is the last index where the error is occurring. So the answer will be from here to here, right? And there are 5 numbers in this subarray, so the answer is 5 for this example. So let's try to understand how we got the answer 5 for this question, right? So let's take a pointer I, okay? This will traverse the array from left to right. So this I pointer is expecting to see the minimum numbers on the left and the maximum number on the right side, right? So the I will detect an anomaly when it encounters a smaller number. Let's say it has reached here, right? We know this is an anomaly, right? We know this part is an anomaly, right? So the I has reached here, but the I already traversed through 10, right? So the I knows that it has encountered a larger number than what it is seeing now, which is 9. So the I will say that this IDX is causing error, store it, right? So we will take two variables called left max and right IDX. Why left max? Because for I to detect an anomaly, as I said, it needs to encounter a smaller number than it has already encountered, right? That means whatever number it has previously encountered must be the maximum. It has to store the maximum number, then only it can determine that yes, this number is smaller than that and this number should not be here, right? When we reach till 9, the maximum number it would have encountered is 10, and after reaching 9 it would have said that I've already encountered 10, 9 should not be here, so it will store the index, right? And now why write IDX? Because imagine we are at this index, right? We have stored 6 as the left max and we have encountered 4 just now, right? So that means it has found the first error is saying that 4 should not be here, because since I've already encountered a 6, there should not be a number smaller than that, which is 4, right? I should not encounter that right now, so it will store that. Okay, as it moves on, or imagine it is currently in this index, there are still elements left on the right side of the array, right, which I has not encountered yet. So that means the next IDX, that if it encounters a next IDX, it will be on the right side. That's why this variable name is right IDX. So that means this variable will give us the rightmost index that is causing an error. So I will give us the rightmost index, right? So from this we understand that when traversing from left to right, the pointer I will give us the rightmost index that is causing the error. So if we need to find the left index, that is the starting index, which in this case is 6, we have to traverse from right to left. So now I'll take a j pointer which will traverse the array from right to left. Now the j pointer from its perspective is expecting to see the array in the descending order form, right? So the j is expecting the maximum number to be on the right side and the minimum number to be on the left side. So for it to detect an anomaly, the anomaly would have to be it finding a larger number on the left side and a smaller number on the right side, right? That is why we'll take two variables for this case also, and those will be right minimum and left IDX. Again, let me explain why right minimum, because as I said, the j expects to find smaller numbers as it goes down the line, right? But we are trying to find the anomaly, and we know an anomaly will only occur if j finds larger number towards this side right? And for it to compare a larger number, it has to know the minimum it has encountered so far. That is why on the right side we are trying to find the minimum so far, right? Let's see this in action. Okay, so J is here. The minimum numbers it has encountered till now is 15, right? It moves on. It says, is 9 smaller than 15? Yes, it is. So it is in the fashion that it expects the array to be in, largest to smallest, right? So 15 is larger than 9. That is correct. It moves ahead. The minimum it has encountered by now is 9, right? And now it sees a 10. So it says that how can 10 be here, because already I have encountered 9. Any numbers after 9 should have been smaller than 9. That means this is an anomaly, and it will store the index of this number 10, right? That would be stored in the left index. And as we move forward, we'll try to find the index on the left side of the array. So that means this variable, just like the right index, left index will give us the leftmost index that has an error. So in the end, the starting index of our subarray will be represented by the left index, and the ending index of our subarray will be represented by the right index. And to find the length, we all know the formula, which is right index minus left index plus 1, and that will be the length of the subarray that we need. Let's continue this dry run. So it encounters 8, which is smaller than 9, the minimum it has encountered till now, so it is correct. It encounters 4, correct again. Now the minimum is 4, right? It stores 4 as minimum because 4 is smaller than 9. Okay, now it moves on to 6, and it says, I've already seen 4, how can 6 be here? So 6 is an anomaly, and it will store that index in the left index, and that will be our answer. So we'll store the index of 6, we'll store the index of 9, and that will be the answer that we will return. So let's write the code now. The first variable we'll always take for every question is n, which is the length of the arrays provided, right? Then the pointers I and j. As we all know, I will start on the left side, so that means the starting index 0, and j from the right side, that means n minus 1. Then we need left max and right min, which will be nums of 0 left max, right? Because initially the maximum number I would have encountered is the first index, right? That means 0th index. And then the right min will be nums of j, the last number, right? And then we'll need left idx and right idx. Both will be minus 1, minus 1. This will help us in a check later, and we'll get to it. So we'll start a for loop, and the for loop will run till I reaches the last index, right? Either I should cross the boundary that closes the loop or ends the loop, or j reaches basically crosses 0, and that will also end the loop. So that means the condition for this will be I less than n and j greater than equal to 0. In this condition the loop will keep running. Okay, now for the ith index, what we are trying to find, we are trying to say if nums of I is less than the left max number, right? As I said, let's imagine we are here, right? Is it smaller than the left max? Left max is 10. It is smaller than 10. That means this is an anomaly, and we need to store the index, right? So we'll store the index as right idx equal to I. In any other case, which is this number becomes greater than left max, if this number becomes greater than left max, we'll store the left max. The left max will be this new number, nums of I. Similarly, if nums of j, then what should be the condition here? Again, what is j trying to see? J is trying to see, as it goes down the line, if the number it is on is larger than the minimum number it has seen, because that cannot be true, right? Larger number cannot be towards the left side. So the condition here is if nums of j is greater than the right minimum number that we have encountered so far. right? In the right side, we have encountered the minimum number. If this number is greater than that, that means this is causing an error. So we'll store it. Left idx equal to j. Else, we have found a number which is what? Lesser than the right min. Then we'll update the right min equal to nums of j, right? And after doing all this, we'll increase the I by 1 and decrease the j by 1. Now, for the check that I was talking about, if left idx is equal to minus 1, in this case, that means there are no errors in the whole array, and we just return 0, right? Otherwise, we return the length of the subarray that we found, which is right idx minus left idx plus 1. Okay, let's try to run this code, see if there are any errors. Okay, so I forgot this I less than n. Let's try again, and the code is working. Let's try to submit, and there's the answer. So cool, that was it for today. If you understood this question, it is kind of tricky for the logic. The code is pretty simple. Try doing it on your own, and like, share and subscribe if you understand anything, and I'll see you in the next one.